Whoa. Hey, I need to get your books out. Turn to page something. Homework to turn in. Yeah, you should have 1-1.7 turned in. The bookwork and
Another one bites dust.
76. I don't know why this is sideways. That's not what I want. Okay, I'm going to write some stuff up here. Get your whiteboard out. F of x is 3x plus 5. And g of x. Different. That's better. 1/4. Nope. 1 over x minus 4. What is f of g of x? While y'all are doing that, I'm going to take a roll. See if you can figure out what would you think that means and what would the answer be? What does it even mean? Just take a guess. Computer is locked. Oh. Let Candace in. Admit. Almost omitted her instead of admitted. Why is that screen? Okay. So Candace is here. I don't see Candace. Do we have video of Candace? I do not have the video. Well, this is really weird. And how about chat? Nothing. Okay, so I'm gonna come over here and I'm gonna make it stop. There she is. Okay, I'm gonna get rid of that. Okay, here's a question that we're trying to answer right now, Candace, on the board. Okay, oh, I'm getting some similar answers. What do you got? You don't have a guess? Task manager. Something's not working. There are no running apps. Then what the heck? Okay, shutting my computer down. Remind me to take roll. Okay, so what did you get? 3 over x minus 7. What'd you get? Anything? Still working on it? I think y'all kind of had a good idea. Yeah. Okay. Okay, so we know that if you were going to, you're listening, you can erase and put your boards up and your pencil up, your marker up. You already kind of knew if you were going to find f of 2, then you would plug a 2 in where x was. And you would get 11. Okay? And so if you have f of g of x, you would plug a g of x in where x was. But what is g of x? So you can say, well, it is 1 over x minus 4 plus 5. Okay, and then once you have that, see if this will go down any, probably not. I'll go over here. Oh, I forgot to click it. There we go. You can distribute here and here, and you get 3 over x minus 12 plus 5, and sure enough, 3 over x minus 7. Does that make sense? James?
Yes.
You're not even looking. Okay, did you put your board up? And your marker? What's in your lap? Okay, well, be looking at the book or up here at the, okay. You got a chance to see everything back and up here? All right, so turn on page 76. Everybody there? This method here of putting a function into another function, like we saw right here, that's called composing functions. Normally, what do you think of when you hear the word compose? Make, put together, create, like musicians compose music, right? But it means, com means with and pose means position. So to put in the same position, sort of. Okay, and so this is composition of functions. All right, now there's other ways that you can have functions interact with each other. Just like numbers, which you can add and subtract and multiply and divide, you can also take functions and add and subtract and multiply and divide. You're warm? Get your jacket on. It's a different jacket. What happened? Oh, it's monumental. Let's close the door. It's like changing your hair color almost. Now that's going to be weird. What happened to Candace? She didn't follow me. Oh, there you go. She lost me. Okay. I'm going to refer to this as Candace now. Okay. So on page 76, they're talking about arithmetic. That's how you say it. It looks like arithmetic. As an adjective, it's arithmetic, combinations of functions. So combination, come over here, are combining functions, are adding, subtracting. What else you think? Multiplying and dividing functions. Dividing. Okay, so adding would be, they say f of x plus g of x. Okay, that's the notation they use. And they wanted to make that shorter and easier to write, so guess what they did? They put the f plus g of x. What do you think of that? They just thought that was better than that. I kind of like this better, right? Yeah, but they do this too. I want you to know that they do that. Okay, and so you also have f of x minus g of x, which is, what do you think? F minus g of x. I don't like it because you have more parentheses. Well, not really. 2 here, yeah, but it's bigger. And then you have f multiplying by g of x You know, I could have written it f of x times g of x, or f times g of x. And then f divided by g of x. That's your multiplying and dividing. Okay, so all this notation, they show in the box. You see in the box there? All the exact same notation, okay? Now when you get to this kind of thing where you have f of g of x, like that, where you're putting a function into another function, that's not adding or multiplying or subtracting or whatever. That's your composition, okay? So let me erase that. Composing functions. So we've got combining functions and composing functions. See the difference? Combining is using your mathematical functions, and composing is putting a function in a function. So we're going to see if you can do the math. So go to the whiteboard. Y'all already did some that pretty amazing, so I don't think y'all are going to have too much trouble with this. Okay, I'll tell you what to write. Okay, so write f of x equals x squared. I give this a turn. No. Okay, keeping going. Okay. G of x equals 1 minus x. So find f plus g of x. F plus g of x. This is the checkpoint at the bottom of page 76. So you're adding, so you changed since you were adding, you said you had a negative x and a positive 1. And then, yeah, but we're not, Okay, so x squared minus x plus 1, or you could say x squared plus 1 minus x is what you get. And then, yeah, it says to find out, evaluate that sum when x is 2. Okay, so how are you going to do this? Write down f of x, and then put plus, and then write down g of x. You could rearrange it, but there's nothing you can really combine. And now find f of x evaluated at 2. So plug 2 in, and I see people getting 3s, yes. Okay? Okay, try the next one. F of x and g of x are the same thing, x squared and 1 minus x. But I want you to subtract them and evaluate when x is 2. The functions are the same.
Okay.
X squared minus 1. Uh-oh. You're subtracting the whole thing. So when you subtract a negative,
Oh, okay.
yeah, watch out for that. Yeah, yeah. And then evaluate when x is 2.
So f minus g?
Yeah, f minus g. And then evaluate when x is 2. 5, like a 5. Anybody else getting a 5? There's a 5. I see another 5. Let's see if Miley and Jesse get 5. Yeah, minus x minus, yeah, you got it. Okay, so to get rid of the parentheses, you'd have to distribute the parentheses. So x squared minus 1 plus x, right? And then you put it. No, that's good. That's good. No, that's right. And then, but she just put them in order of descending powers. And then when you plug 2 in, okay, let's try another one. We're going to have a couple different functions, okay? Wow, that was supposed to be the same one. Okay, f of x is 2x plus 1. G of x is x squared plus 2x minus 1. Oh, that's the example. Let me go back and change it. Let's go back to our original. F of x is x squared. G of x is 1 minus x. Find f times g of x. F times g of x. It's the checkpoint in the middle of page 77. I got any, oh my goodness. Okay, everybody get them. Okay, go ahead and distribute. What is this?
X minus x, the cube.
Ah, 1 minus x, yeah. Wait, but no, something's wrong, Okay, this is x squared. So x squared times 1
That's x.
squared.
So that's just 1.
No, okay, write down the, like if you're multiplying,
I
f
see.
times
Here we go.
g of x. Then you're gonna have x squared and then 1 minus x. And then distribute.
Okay.
Yeah, x squared minus x cubed. Okay, let's see if there's another part to that. Evaluate the product when x equals 3. When x equals 3. Well, you're all erasing.
Oh, wait.
Do you know what? X 3 squared, 3 cubed. And maybe you can help me, Travis. I've got my chat coming in sideways, and so are my pictures of Candace. You have to tell it. Let's see now. It wasn't doing it yesterday. You getting dizzy, Candace?
Sorry, Candace. Come on.
Did y'all get negative 18? Yeah, good. Okay. Now let's do a quotient. This one's going to throw you. Okay. Let's see. F of x equals the square root. And in the square root is x minus 3. Oh, no. Well, see, she's still sideways. And g of x is in the square root, 16 minus x squared. And find f over g and find g over f. But don't erase when you get it. Let me turn this off so it's not moving. Oh, what are you doing that for? For the whole one big radical? They did not do that. On these quotient ones, you just set one over the other and then don't try simplifying. Don't try simplifying, okay? Yeah, you just put one on top of the other and then you leave it. But here's where it comes tricky. No, well, that's 4 minus x, 4 plus x. It's not an actual square of anything. So the deal is, what's the domain of these guys? Oh, thank you so much. That looks much better. Okay. Can't have what?
Can't be. These functions just can't have the result of this.
You can't have the denominator be equal to 0. One of them is x minus 3, and you have 16 minus x squared in the denominator, right? And then one of them, you have the 16 minus x squared in the top and x minus 3 in the bottom. Okay, so here you're looking at this. Oh, hang on, I gotta put this back on so she can see what I'm doing. Come on, come on. Oh, it's moving now. Okay, there we go. Which one was this one? F over G. F over G of x. And this is G over F of x. Okay, y'all listening? Over here, James? Okay, here you're looking at the denominator. That's all you really care about? Actually, not really. Because this is something I think a lot of y'all had trouble with. So the denominator can't be 0. So you can write 16 minus x squared, you could even do the square root, is not equal to 0. Okay, then we square both sides. What's 0 squared? 0. And then I'm going to move x squared over to the other side. So it becomes positive. And then take the square root. I got plus or minus 4. That can't equal. So x can't equal positive or negative 4. Okay. That would give you a denominator of 0 for this one. And also you would notice up here that if you had, you would notice that x minus 3 has to be greater or equal to 0 because what's the problem with having it less than 0? Square root of a negative, which is undefined. And so I'm going to move my 3 over to the other side. X has to be greater than 3. And so this and this together have to be my domain. Let's see. And so really, if x has to be greater than or equal to 3, it's already, that's going to take care of this negative 4 down here, right? If x is greater than 3, it's not going to be negative 4. So I don't even need to put that. So it has to be greater or equal to 3, but not equal to 4. Okay, that's the domain. Now on this one, you kind of treat it the other way. Here, x greater than, let's see, it has to be greater than or equal to 0. What do we say, 3? And here, x cannot equal 4. But anything, you don't want imaginary or 0 in the bottom. Basically here on this one, you can't be 3 and x has to be greater than 3. So it's not greater than but not equal to. Okay, so you have that and that together. Okay, so it kind of changes things a little bit. You have to look at the domain of the top and the bottom. But the bottom especially because of division by 0. Okay, let me see if we have something else. Composition. Y'all already did one composition. I'm going to give you another one. Oh, sit down first. I got to go over some more notation though. Erase and sit down. Did y'all go over this stuff in Algebra 2 last year a little bit? Does it kind of ring a bell? COVID, just say COVID and everything's understood. Okay, y'all were doing f of g of x, and you kind of knew what that meant, was to put g of x, let's say substitute, in for x in f of x, right? And I like this notation. It's kind of, you know, nested parentheses kind of thing, but they came up with another notation for it. They call that FOG. So it looks like fog. That's not really an O. It's like a little circle in the middle of the space. Like an O would be like that, but we're doing a little circle up here. But not a dot, because a dot means times, multiplication, right? So that, and so then you put your x here. And so when you have it like this, you have to remember that you're putting g into f because it's like this. You put the one that's closest to the x into the other one. So if I say G-O-F, goff, then I'm putting f into g. Okay, I think it's real clear here which one you're putting into which, right? This one you have to remember, but that's what they use. Why do I have 2 lids? Oh. Let's see. Okay, y'all go up to the board. Got any examples already? And write down f of x equals x plus 2. And g of x equals 4 minus x squared. So for A, I want you to find f composed g, FOG of x. I'm not sure how you're supposed to exactly say that. How do they say it? Do they say it's just f composed with g. That's what they say, it's f composed with g. And then b, I want you to find g composed of f of x. And then c, I want you to find g composed of f of 2. Okay, so here. Here, I'm gonna put f. And I want you to FOIL. If you have x plus 2 in parentheses like you should FOIL. Let's see, I'm gonna get rid of that. No, I'm not gonna do that. I'm gonna make 8. 4. No, 4 minus 4 is 0. Let's see if I got them right. Negative x squared plus 6. So what'd you do? Oh, did you get it? And then negative x squared plus 4x. Did you get that?
No.
What happened?
Math.
Yep. See how when you put f of x is x plus 2. When you put it in here for x, it's squared. So it's x plus 2 times x plus 2. And then you have to say 4 minus all of that. So try again. Oh, but no, wait. Because see how it's like this? So you have to subtract that and subtract that and subtract that.
Change all the signs.
Yeah, change all the signs. And so this would be that's negative 12. Negative 12.
Just totally negative there.
And that's not right.
That's all right.
Yeah.
That's
A negative x squared minus 4x, right. The goal is to do it on your own without looking at anybody else's. Negative 12 for that last answer. How's it going over here? Okay, so no, you don't just distribute the power. That's saying this. Watch this. It's saying x plus 2 times x plus 2. That's what x plus 2 squared is.
Oh.
All right, which normally we don't do that. We'll just go ahead and FOIL it. Yeah, x squared, 2x, 4, and put all that there.
Okay.
Kylie, I can almost see what you did. Actually, I can't. See the negative 12. Okay, good. Okay. Okay, I want to.
Hang on.
Mhm.
Wait, x is 2. So you plug this into x, right?
No, okay, for this one, you're plugging F into G.
Oh.
Did you switch them? It's confusing, right? Whichever is closest to this thing out here, that's what you put into the other one.
That's 4. So 4 minutes. Okay, negative 12.
Did you? But you got the right answer. Okay. Oh, okay. One thing that you can also look at, I think this might have been what you were doing. Were you finding f of 2 and then plugging that number into G?
I did
You put 2 in there?
2 in there. That's 4.
Right.
4 squared is 16. That's negative 12.
Yeah. Okay. So what I did, y'all look at this. What I did here. Wow. Let me see. Once I got this G of F, then I just plugged 2 into it. But if you think about it, it's G of F of 2 you could plug 2 into f of x, and what would you get? 4. And then plug 4 into here, 4 minus 16, and you'd still come up with your negative 12. How many of y'all did it that way? You plugged it in there and then there, or did you plug it into this? Ah, okay, so there's 2 ways you can do that. Okay, have a seat for a second. I'm going to read all of the numerous chats that, oh, now there's only 2 of them. Nope, there they are. Well, I just missed them again. Too pixelated. You can't read the board. Okay, there we go. Is it still pixelated even now? Candace? Oh, she's frozen. Let me go back to the chat. Okay, chat. I see nothing. Since evades me, the camera's crooked. Okay, I can't read the board. I can't do that math. Ah, camera's fixed. Okay, where are we? Okay. Poor Candace. We zoomed through 78. We're all the way to page 78 now. And your picture's still frozen. Oh, now you're totally gone. Or the screen did something weird. There you are. That was weird. Okay. I'm gonna tap some more. Where are we? Okay, so where are we right now? We're on page 79. Okay. Actually, look on page 78. I'm going to make the chart up here, and we're going to talk about that. Because y'all were doing algebraic stuff with functions, with actual algebra, right? And there's also the numerical stuff. Remember we talked about different ways to represent a function numerically, graphically, verbally, and what was the other one? Graphically, right? Okay, so they show that if x is 0, 1, 2, or 3, you see this in the margin on page 78? Then g of x is 430, negative 5. Then they have another chart, and they say if x is g of x, okay, I don't want to do that yet. Okay. G of x. Oh, okay, that's what they're doing. Yeah, that table's not doing what I thought it was. What I want you to do then is actually go to, don't see it in the homework. Maybe they're not going to have you do it. I guess they are. Okay, so never mind. I'm just not going to do it then. It'll be, sometimes they'll give you charts of f of x and g of x. And just from the data table, you have to find f of g of x. But they're not doing that there. They're kind of showing you with the equations what they get. Okay, now look on 79, they're talking about finding the domain of f of g of x for the functions, and then they give you 2 functions. Okay, f of x equals x squared minus 9. Okay, g of x equals the square root of 9 minus x squared. That's weird. They both have 9s and x squareds and a minus, but they're still different. And then they show f o g of x. And sometimes when you're doing these, it's good to go ahead and rewrite it as f of g of x, like that, just to remind yourself that you're putting g into f. Okay, and so in this case, here's f. So f is, and I'm going to put a parentheses here for x, because I'm writing f of something. So I'm writing, here's the x squared, and here's the minus 9. And so in for x, I'm going to put g of x, which is square root of 9 minus x squared. And what happens? What do you notice happens there? Square root and the squared going to cancel, right? And so you end up with 9 minus x squared minus 9, which gives you negative x squared. Okay. And they say from this, it might appear that the domain of the composition is the set of all numbers. Because you can put any numbers you want, and any number can go into here, because you can take any number you want, square it, and take the opposite, right? But it's not true, because the domain is the set of all real numbers, and the domain of f is a set of all real numbers. Okay, this one, the domain, well, I'll just put colon, is all real numbers. But this one, the domain, x has to be greater than, I'm sorry, 9 minus x has to be greater than or equal to 0, remember? Because it's in the square root. And if I move that over, I'll have or x squared is less than or equal to 9. And then you take the square root, and I guess it's, you get weird things with the 3's. And they say the domain of G is from -3 to 3. Do you remember that? How can x squared be less than or equal to 9? Think of it this way. Something squared has to be less than the distance away from 9. No, let's see. I didn't state that right. Here's -3, here's 3. Okay, if I square this, I'll get 9. And 9 minus 9 is 0. And so this will give me 0. Anything over here is going to give me a negative number in the radical. And if I have regular 3 here, I'll get 0. And anything above that will give me a negative in the radical. And so the only thing that works is from here to here. That's the domain of g of x. And so when I compose f of x with g of x, that changes my domain from all real numbers for f of x to only from here to here for the composition of them. Does that make sense? In other words, when you're looking at domains, you have to see which has a more restricted domain and go with that domain. Does that help? Go with the most restrictive domain. Okay, back to the board. I'm going to give you a couple to try. And I'm also going to turn this around. Nope, that didn't work. That didn't work either. That is not working either. Okay. Admit. She's joining all over again? I'm getting 2 Candaces.
Maybe on a different device.
Ah, that should be interesting. Are you on 2 devices, Candace? See what she says on her chat. All my chat is gone. Not what I meant, but thank you. I am, well, this, I'll just ask you. That's probably best, Candace. I'm going to type in OK and send. Okay, so I don't know what's going on. Okay, here we go. F of x equals square root of x. F of x equals square root of x. G of x equals x squared plus 4. Find the domain. Well, first let's just find f of g of x. Like that. Okay, square root of x squared plus 4. Okay. Now, over by your g function, what's the domain? Put the domain of g of x. You just have x squared plus 4. What's the domain? And that is not right. No. No, because you can't just take the square root of both of these separately. Because what times what is going to give you x squared plus 4? Because if you have x plus 4, like you said it was, when you square that back, you're going to get x squared plus 8x plus 16. That's not the same thing. Okay, all real numbers? Good, all real numbers for g. I mean, yeah, g of x. What's a domain for f of x?
All positive.
Yeah, x greater than or equal to, you should say non-negative. Okay, and so what's the domain of f of g of x then?
X not equal. I'll have it.
All real numbers? You can put any real number in there?
Yeah. It's 2. You can put -2. It's positive 4. So anything, even 0.
Yeah, because anytime you square anything, it's going to give you a positive number. So you'll always have a positive number in there. Let's see what they said about this. They didn't say anything of this. Yeah, however, listen up, guys. If you're composing these, let's see, F. You can't, yeah, because you can't just look at this and say, oh, that looks like it's all real numbers because you're using this in there. So I think you have to say x has to be greater than or equal to 0, even for this, because you can't compose a function with another function when one of the functions' domain is limited, okay? So you have to say it has to be x is greater than or equal to 0 too, even though by itself it doesn't look like it. But as a composition, it's still like that,
So
okay?
0 is positive or negative?
Neither,
Okay, so it isn't even. Darn.
yeah,
Yeah.
no.
I was going to say, that means that there's always one more positive than there is negative at all times.
No?
If 0 was positive, that would mean every other.
Right.
Yeah, I was like,
Yeah.
time to break people down.
Okay, one last thing. Write this down. Erase what you have and write down. H of x, little h of x,
Oh, no,
little h of x equals 1 over, no slanted lines, nope, 1 over x minus 2 squared. But put x minus 2 in parentheses. X minus 2 squared. Okay. Now, that is actually a composition of two functions, and you got to tell me what the two functions are. Like what's f of g and what's f of x and g of x?
What?
Like h of x is f of g of x.
Okay, wait, I see. So,
We're going backwards now. So what would g of x be? What would h of, I mean, f of x be?
yeah.
Okay, and believe it or not, you can have more than one right answer. You are correct because you plug G in and you got the same thing. You are correct because if you plug G in, you'll get the same thing. Let's see what Eddie gets. You have an idea? No.
I don't know.
Okay, the parentheses can maybe help. Maybe what's in here is one of the functions, and then 1 over x squared would be the other function. Does that make sense? Like
Oh, wait.
if this was 1 over x squared and this was x minus 2, then plugging this into here would give you that, right?
Oh.
See? Let me see what y'all got.
What's the other one?
What'd you get? Where's your minus 2 come from? Oh, wait, this is. Now fix it. Kylie, what'd you get? You're still looking, huh?
What's the word for non-prime number?
Composite.
Composite, you're close.
I was close. I said composite.
Okay.
That's a medication. Never mind.
So maybe think of this right here. X minus 2 could be maybe g of x. And you plugged it into this. So you plugged x minus 2 in here for x and got that. Does that make sense? Another thing, huh?
Oh yeah, I guess.
And then what did, he erased it already. You could also say, oh, this whole thing could be one function. We'll call this like that, and then maybe f of x is just that. That would work too. Okay, let's see if I want to give you a, yeah, good job. Okay, try one more. When do we got time? What do we get out?
24 minutes.
Good, okay, good.
Outside.
Okay, write this down. H of x equals. Okay, the cubed root of 8 minus x all over 5. Tell me what f of x is and what g of x is. What did you plug into what to get that function? And there's more than one right answer for these guys.
Is G inside of X or is X inside of G?
G is inside of x, let's just say. Yeah, that would work.
There we go. That's totally a 3.
What? X minus 5. Wait, what?
The backwards E, it works.
Believe it or not, his works too. That's crazy.
I
Yeah.
don't like this because this means I can be wrong in multiple ways and right in multiple ways.
Let's see what we got over here. Okay, you did the same thing James did. Brain empty. Okay, so think of this as two things.
Yeah.
What did you do? Think about this. Focus in on X. When you plug a number in, the first thing you have to do is subtract it from 8, right?
Yes.
So maybe you have 8 minus x is the first thing, the first function. Then you have to take the cubed root of it and divide by 5. So you could say
Okay.
this and put that in there.
Yeah, I'm overthinking this.
I think so.
Yeah.
Yeah, you're just kind of pulling it apart. And see, this is different from hers. Because see, she said, well, now I'm going to have x over 5, and then all of this is x. That's the same thing, yeah. Okay, you ready to have a seat? Why is what?
These are the tests. Do you have like every possible answer?
No, they just say answers may vary. And then I'm just stuck figuring out if you're right or not. Or they may say sample, and they'll give it one answer as a sample. So if you're putting two together, and that's called composing a function, what do you call it when you're taking it apart? Decomposing. Actually, that's what it's called. Okay, so here is the assignment to start working on, and you can work on the board or on your paper. And in fact, I think I might have y'all go at least at the board for 1 through 4 all. And then we're going to continue on Monday with 5 through 19 and 31 through 53 odds. The end of the section. So what is that? 81. Section 81. Okay, so go to the board and do 1 through 4. You've got some fill in the blanks, and you've got, let's see, use the graphs of F and G to graph. Oh, this is the tricky one. Yeah, okay.
Strikes again.
Are you okay? They dropped you. Did you not look? I just wanted to know. Let's see if it's. I was cranking down the hall and it fell off.
They need to like add like something to clamp it on the sides.
Okay, so don't do it on the table. I may have to end up putting up higher on that side of the table. That might work better. Let me try that. I might get a. Okay, another app is using audio now. So you say. Okay. Okay. Let's see if we lost her for good. Oh, here we go. And start recording with swivel. I don't want to record with swivel. Okay, let me. Ah. Candace, are you there? Are you green? Aha, I see you looking at me. Are you with us now? Okay, so I'm going to work some of the problems up here that we're talking about. Maybe that, can you hear me? Can you see me? Okay. So, okay, the arithmetic, okay, when y'all put sum, difference, product, quotient, those aren't the actual operations. Eddie got the actual operations. Okay, you need to change these.
Oh.
These aren't the operations. Eddie has the operations.
What?
Sum is not an operation. Addition is. Addition is.
Can I just leave this here?
Wait.
If you look at
No.
the example.
Give me.
No.
Give me more.
And then you got subtraction, and then you got multiplication, and then you got division. To create new functions. And then two, the blank of the function f with g is f of g of x or f of g of x, f of g of, yeah. So what is that? What is two? Did y'all get that one yet?
It's
Eddie got it.
That's somewhat like.
Composition, yeah.
No, it's not.
Yes, it is. Addition, subtraction, multiplication.
I can read.
Okay, now look at number 3. Oh man, here it's all my stuff, or I did. Okay. James, back at the board. Number 3. Go ahead and plot those points on the whiteboard. 1, 2, 3. 1, you got a dot here. You got a dot here. 1, 2, we got a dot there. We got a dot here. And we got a dot here. Only theirs looks more bent. Oh, it looks like it's at half. I want you to put some numbers on there. Okay, put the numbers in there. This is 1, this is 1, this is 2, this is 1. This right here, I think, is at 1/2. From what I can tell, yeah. And then I've got something up at 2, and then up at 3. 1, 3, and then 1, 2, and then we got 3, 2. Bump, bump, bump. Okay, so they want you to graph f plus g of x. Okay, so get a different color marker. You can use red. Nope. Where'd my marker? Get a different color marker.
Dark black.
And they say this one is F and this one down here is G. And so to do F plus G of X, you're going to add, like when you got 0 here, you got a -1 and you got a 2, right, on the y-axis. What is 2 plus -1?
1.
1. So put a dot there. 2 plus -1. Did Kylie get that? Does that make sense? No. You're looking at the y-axis. You see your 2 dots on the y-axis? You're going to add them. Y is 2 and y is -1. And when you add that, you get 1. What about at 1? What are your 2 dots? 0 and 3, right? So what's 0 plus 3?
Sorry.
So you got another dot just right there. What is, when you get to 2, you got 1/2 and 1. What's 1 and 1/2? No. 1 1/2. So it's like about right there.
1 and 1/2. Okay.
Yeah.
Like what?
1 and 1/2. The next one, you got a 0 and a 2. And so that's at 2 again. So now connect those with that color, and it looks like that. And so you see what happens when you add this function with that function, it's going to look like that graphically. You just add each, the y value for every x and graph the new. Does that make sense? Okay, see if you can do 4 on your own.
Adding graphs doesn't feel right.
Too bad. So we got going out to 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. At every x, you add up the y's that are on that vertical line. You look at vertical lines basically. So first you got to plot all the points. So I've got the origin. And I've got 2, -2. -2, 4. That's right here. I got 2 0. And I've got 4, 2. And I've got 4, 4. Oh. Okay, straight line, straight line. There we go. Okay. Then get a different color to do the addition. Oh, you need to see the original ones. That doesn't look right. You're supposed to do 1, 2, 3, 4 points. They don't even have all of that.
There's not a point on there.
Well, you can still have one there. Looks like it's at 2, 2.
That point goes down to that one goes down to here.
I know.
Wait, do we have,
But
so we have to have 5 points and not the ones that are.
Well, they don't have just the dots. They have the lines themselves. And so I think you do. Like at 2, you got that. And like at 1, you have that.
What is the answer?
0. Here you have the 1, 1. And here you have 1, 3. Okay, well, let's try it and then we'll see. Okay, hang on. What do we got at 3? We've got 1 and 3. 1 and 3, yeah. Okay, so 1, 2. So at 2, I've got 2 plus 4. Let me get a different color. 2 plus 4 is 6. 2 plus 4 is 6. Here I got 1 plus 3 is 4. Here I've got 0 plus 2 is 2. And here I've got 1 plus 1 is 2. Here I've got 2, and I got 0 plus 2 is 2. Here I've got 1 plus 3 is 4. And then 2 plus 4 is 6 again. So it does, it makes kind of a weird looking
Okay, well,
U.
let's try that up.
It has a flat bottom here because this crisscross thing is, and you should have a flat bottom at y equals 2. See, you're only doing the dots, you're only adding the dots together, but you have to add every y, every x, at every x, add those y's. Let's see, I'll see what it looks like. Well, they don't have, I don't think they have it back here, do they? In the teacher edition. 4, 1, 8. They might. Ta-da.
Oh, all right, yeah.
Yeah. Okay, so it's not just the big dots that they show on the grid. You got to do, like they showed these dots and these dots and these dots. But you have to think, well, where's this and this? And where's that dot? Where's that dot? Thursday, Friday, 25. Okay, why don't you go back to your desk and start working on the 5 through everything. 5 through 19. And 31 through 53. Odd. James, I haven't signed a planner all week. What's up with that? Well, to go get it. Oh, I erased mine. But if you look, sorry. If you okay, like right here at the on the y-axis. Oh, are you drawing the new ones? Oh, you're redrawing it. Okay, I'm sorry. Yeah. Is this your 4?
Yeah, I know.
So you know how to do it right now?
Yes.
Okay, so start working on the other stuff on your paper. Like get paper out, get a pencil out. You're not doing it.
I had spinning.
You need to go to the office. I don't know if you can't do work. I'll let your mom know. She can come get you. Yeah, and so like where x is 1 here, you've got a 1 and another 1. And so you add 1 plus 1, you get 2. And like here you got 0 plus 2, you get 4, and that kind of thing. At each y, like at each integer, add what they are.
2 plus 4 is 6.
Yeah. And then here, they don't show any dots, but it looks like it's at, if you look at the actual thing, at -1, it looks like you've got a 1 and a 3. Like if you were to put a dot there where that line is, above the 1, it's like you've got a dot at negative 1, 1, and a dot at -1, 3.
So here?
Yeah, and then this should be going through 3.
Okay, so like right there.
Yeah.
So
That
1
equals
plus 3.
4.
So then that's like right there.
Uh-huh. And then here you got 0 plus 2, which is just 2.
So
It goes just right on that same thing. Then here you got 1 plus 1.
So it's right there.
And then there's 2 plus 0 again. I mean, 2 plus 0 again. 0 plus 2.
So there's another dot there.
Uh-huh.
And then
And
4
then
plus.
what about 3? I think it's at 1 and 3 again. And so it gives you another 4. So it's like a symmetrical.
Oh, and then it.
Yeah. Yeah. Why is she turned around?
I mean, if Candace was able to control it herself, she just.
She's not. What did we say the page was? It's 81. Use class time wisely. I might have to write that every day until you kind of start using class time wisely. Yes, but I want you working in class now on it. When do we get? 25. Yeah, we get 4 minutes, so you can't do a whole lot. Any of the prophets or priests would like to add their, I can't see the rest of the.
Yeah.
On what Monday? On this? Yes, we are. And we'll also be working on the success organizer. Oh, I missed several of these. If any prophets or priests would like to add their handprints to the martyr banner, some martyrs and I will be in the cafe right after school. Did y'all hear that? Did y'all do that at lunch? You're going to? Spirit Week, come on. Okay. Let's see if I've got anything I can do for. Okay, so Candace. I still haven't got around to your questions from yesterday, but I will work on that after this class because I don't have a class after this class. And so go ahead and work on questions from this thing. They shouldn't overlap too much. If you don't know from last section, it shouldn't affect what you do on this section. I would suggest all you're doing on here, it makes it look complicated, but all you're doing are adding functions together or subtracting them from one another. Just like you've always done. If you've had x plus 2 times x plus 3, you can FOIL that. And so it's just kind of like putting together algebraic expressions with algebra. That's all it is. They're just, the notation is kind of weird. But go ahead and see what you can do on it. Does it help you to do the organizer before you do the homework out of the book? Do you learn from the organizer handout? Are you typing? You look frozen. Oh. Cat. Yeah, she's totally, oh, she's gone now. Okay, well, I lost her. There you are. I think I must have had you on 2 different. Oh, you're here now.
Lost internet there. Okay. Well, I didn't really hear what you said.
I don't see where I have you. Okay. Chat. Nobody lost. All righty, guys, y'all can go when your desk is clean. Lost internet. Is that what happened? You lost internet? Okay. Candace, I'll send you some links to some stuff, some videos to watch on that. You think you can try them. If they don't help, let me know, but at least try them. Okay. Then I'll let you go. Yes, and send more. I mean, I got your questions from last time, and I'll work on that right after this period. Bye-bye. So I'm going to let you go. We'll get you caught up. Don't worry about it.